Have you ever wondered what limits are in mathematics? Well, buckle up, because we're about to delve into the fascinating world of mathematical limits. Imagine you're on a never-ending journey, constantly moving closer to a destination, but never quite reaching it. This is the concept of a limit in mathematics. Let's take a look at a concept called the epsilon delta definition of a limit. It's a fancy term, but don't worry, we'll break it down. This definition states that for any function and any real number, if the function gets closer to a certain value as the input gets closer to another value, then for any positive number epsilon, there exists a positive number delta. Here's an example. Consider a simple function, 1 divided by x. We want to show that as x gets closer to 0, the function shoots up towards infinity. To do this, we need to find a delta for any given epsilon. Let's say epsilon is 1. We want to find a delta so that if the absolute value of x is less than a delta, the absolute difference between the function and infinity is greater than 1. The function is always positive for positive values of x, so we only need to consider when x is negative. We want to find a delta so that if x is less than 0, the function is less than -1. The smallest such value of delta is 1. So for any positive value of epsilon, there exists a positive value of delta, so that for any x within delta of 0, the function is within epsilon of infinity. This shows that the limit of the function as x approaches 0 is indeed infinity. The epsilon delta definition might seem abstract at first, but it's a powerful tool for understanding and working with limits. It allows us to make precise statements about the behavior of functions as their inputs approach certain values. So next time you're on a never-ending journey, remember the concept of limits. You may not reach your destination, but you're always getting closer. And in the world of mathematics, that's what really matters.